Up until now, when you've defined a function, such as this print repeated function that has two parameters, and you've called this function using a function call expression, we've used a technique called keyword arguments to specify those arguments in the function call. Let me put an example to this. So print repeated, message is hello, and times is 3. These are the arguments that we're passing, and these are keyword arguments. The notion of a keyword argument, the naming of this is a little bit silly. I wish it were parameter bound arguments or something like this. But the idea is we're saying message equal as if we're saying message is assigned or times is assigned. And these names correspond to the parameters we defined. So when we call this function, we see, okay, message was hello, and hello was printed 3 times. And we could look at this function implementation. We see, yes, this is what the docstring says it's going to do, print message some number of times. And we can think about what this implementation is doing in just a moment, but it's printing message some number of times in a while loop. We could try this again with 5 times and see that 5 times over, hello gets printed. But the point of this video is to focus on how we're passing these arguments. And we have so far been using these keyword arguments where we say parameter name equal and then value, parameter name equal and then value. The reason why we start out this course in this way is because this helps make a very explicit connection between our arguments that we're passing to our parameters. It also gives us an intuition for when we start to have local variables. We could define a variable such as message string in our globals frame that's assigned, by. And notice that up in globals, we now have the string by, and we can reassign this to be something else, right? Message is hello again. The point is, this syntax is very similar to the syntax of keyword arguments, where we're saying message is hello, but this assignment happens in setting up the frame for the call to print message. Well, today we're going to learn another way of passing arguments that's a little bit shorter, a little bit more concise, and is based on the position in which we define our parameters in the function definition. So to make that concrete, this is the first position argument parameter in our definition, and this is the second position parameter in our definition, right? Message is defined as the parameter before times. So how would we call this using a positional parameter, or positional argument, I should say? Print repeated, and we can have a message like hello and 3. And notice this works just the same. We didn't need to provide the parameter name equal symbol and then argument value. We could do this just based on the ordering of these parameters in the definition and the ordering of these arguments, hence the name positional arguments. If we made a mistake here and we actually accidentally included an extra one, like say 3, notice we get an error here. Print repeated takes 2 positional arguments, but 3 were given, right? And so this is what Python is referring to when you see something like positional arguments. It's the position in which we're passing these arguments in. So if we said 5 instead here, we see that that works out. Now notice position is important. If I tried calling this function with 5 and hello, we would see that we get an error because this doesn't make sense. While times, but times in this case would have been assigned the string hello greater than 0, that doesn't really make sense. And so when you try and call functions with the incorrect order using positional arguments, your code editor should give you some hint that, hey, it looks like you're actually calling this function in the wrong way. You're passing these in the wrong order, or maybe you're calling this without enough positional arguments. For example, similarly, if we call this with just hello, we get the error print repeated is missing 1 required positional argument named times. And so that's what helps us ensure that our function calls are corresponding to our function definitions. One other little tidbit that I want to point out in this particular video, because we haven't seen this concept before, but notice we're passing 5 to times. So times is this integer parameter here. And if we were to draw the environment diagram for this, we know that in the frame for this function call, times would have a value of 5. And then notice we're saying, well, 5 is greater than 0. And then we're using the relative reassignment operator to subtract 1 from times. We haven't been modifying or mutating our parameters as we've been evaluating memory diagrams so far, but there's nothing stopping us from doing it. times is, in fact, a local variable in that frame for print repeated. And if we change it, it's not going to change something outside of this. So for example, if let's say we had a variable that is, say, expected repeats is an integer that is, let's say, 10. So notice expected repeats is now a local variable here. And now I can use that as as my argument to print repeated. So print repeated, message is hello, and expected repeats is the integer that I'm passing in. And notice that it's printing out 1, 2, 3, 4, 5, 6. And if we were to count them up, we'd see 10 times. But notice that expected repeats is still 10. And so even though we are modifying this variable inside of the context of this frame, because we copied that value in, we had to copy 5 from expected into the frame for times, we are not actually changing expected repeats outside of that function call. The point of this video really is to emphasize that once you've defined a function, you can use positional arguments to call it, and you don't have to say, you don't have to use keyword-based arguments like we were at the very start. So again, as the contrast, keyword argument is message and times, right? That does work, but moving forward, you're going to see that we in our examples tend to use positional because it's a little bit more terse. And in fact, when you use other programming languages, most programming languages use arguments in their function calls in this way and not using keyword-based arguments. For completeness, I'll mention one last thing, which is you can combine these. So times is expected repeats. So you can say, you can combine these as long as the positions are initially correct. The last thing I'll mention is that as you learn more advanced Python, you can use keyword argument style to do some things that you can't do with positional arguments, but they're beyond our concern right now. As you continue your Python journey, you may encounter other uses of keyword arguments that are pretty cool. And the gist is sometimes you can imagine functions which may take lots of potential inputs, but have really sane expected defaults for most of them. But you want to be able to change just 1 or 2 of those things. It would be really tedious to have to provide a giant list of arguments when most of them are always going to be the same. And so Python has a cool way of saying, we're going to make some of these arguments special, and only the ones that you provide using keywords, which allow us to know exactly which ones are passing, are what we're going to use. We won't be seeing that in this course, but we did start out with keyword-based arguments, and you're welcome, if you're comfortable using them, you're welcome to continue using them in your code. But just know that when we start to see examples moving forward, we're going to be using positional style arguments because they're more conventional in the ways that we're using them, as well as in many other programming languages.